Okay, so the cancellation method, as the name suggests, is about cancelling the terms of the recurrence after kind of unraveling them. Let me show you an example instead of reading through this thing. Yes, okay, so here's a recurrence. Remember, a recurrence would have two things. One, uski stopping condition, okay, which is okay, what happens with the recurrence when the value is very small. That part is not going to be recurrent. Okay, it's just, for example, AF0 is 1, AF5 is 1 or whatever. Okay, it's going to be the value of the recurrence on a small number. And the second part is the recurrent part, where we say that how recurrence is related to itself. Okay, and that's what comes from the recursion. Thank you, Altaf. Alright, so over here we have a stopping condition which says that AF0 is 1, and we have the recurrent part which says that AFN is AFN minus 1 plus 2. This, I believe, is super easy to solve using substitution method, and I hope you guys can do it, and I want you guys to do it using substitution method, but we are going to do it using something called the cancellation method. Okay, so what we do is we do what we do in the substitution method. That's where we start. We write AFN, and then we write AFN minus 1, AFN minus 2, and so on. Okay, but we keep doing it until we see that we will get a term which is the same as the stopping condition, or at least very close to stopping condition. Okay, it's possible that you stop at AF1, for example. Alright, but we are not gonna replace the value of a of n minus 1 from this thing, okay, as we used to do it in the substitution method. We're just gonna keep it. So far so good? Everyone with me? Hanan? No? So far मुझे issues बताओ. So far. Oh, substitution method or cancellation method? You want me to go back to the substitution method? Okay. 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 Let's not poop on my plans today. Okay. we'll go to the substitution method if we have some time at the end of the class. Otherwise, I'll do it next time. Okay. But I'm gonna do it. Okay, I owe you. I promise you, I'll do it. Okay. But today we are going to do the cancellation method. Let me know whatever I have said, if any of that does not make sense so far. Okay. Okay. Good. Awesome. But I really like this thing about Hanan. He is very outspoken. If there is something he does not understand, he kind of says it out loud. Okay, and it's super great. This is super nice. This helps me gauge what's going on in the class. Okay, so kind of replicate that. Okay. Say it out loud that this does not make any sense to me. All right, awesome. So back here, so far so good. Any complaints? All right, I want someone to guess what I'm gonna do with this thing. Look at the name of the method and what I'm gonna do with this. I'm gonna do cancellation. Okay, what I'm gonna do is I'm gonna have things on the left, and I'm gonna have things at the right. Okay, and if I sum them up, then most of the things would cancel out. Okay, so for example, this a of n minus 1 would cancel out because there is an a of n minus 1 on the left, and there is a thing which is called a of n minus 1 on the right. Okay, a of n minus 2 would be cancelled. All of these terms, all of these recurrent terms would be cancelled. Okay, you would still have 2 of n, you would have 2 times n, you would have 2 times n minus 1. These terms would be there. You just need to count them, but the recurrent terms would be gone. Okay. Awesome. So that's all about the substitution method. You would be left with a of n. A of n would not be cancelled with anything, and you would be left with a of 0. A of 0 would not be cancelled with anything at all. Okay, so you would have a of n, a bunch of terms, and then a of 0. Okay, and that's it. That's what you want, right? Once you have that, you can apply the everything we learned about the summation of the sequences to this, and then you would have an answer. Okay, let's do that. So what I did so far here is that I wrote a of n as this, a of n minus 1 as this, and I kept doing it until I reached. So what I was doing is, in each term I was removing 1 from the index of the term. Okay, I started with a of n minus 1, a of n minus 2. So the subtraction terms was increasing. Okay, so the last subtraction term would be n minus 1. Okay, I will start with 1. When this is AF, this is n minus 1, this would just be AF1. Okay, and this would give me AF1. AF1 would be AF0. Why did, oh yeah, so it's AF0 plus, so what I'm doing is I'm putting AFn minus n minus 1 in this formula. Okay, so I would get 0 here, and then 2 times n minus 1. Okay, which just says that it's AF1 is equal to AF0 plus 2. Okay, I will sum things up, and this is what it looks like. Everything else cancelled. I would have AFn on the left. Okay, and on the right I would have this 2 of n minus 1, 2 times n minus 1, 2 times n minus 1, 2 times n minus 2, and so on until the last term would be 2 plus AF0. Excuse me. Okay, AF0 is just 1 from the stopping condition, and that gives me the answer. This is the sequence form. इसके अंदर कोई भी एक ही term नहीं है. So this is just 1. We know this. Okay. So it's just 2 to a 5 where I goes from 0 to n. And we know how to sum this. Okay. The problem with cancellation method is for the most recurrent problems, this cannot be applied. You cannot have things which cancel up, because you would have something like 2 times AFn minus 1 here, and you would have just AFn minus 1 on the other side. Okay, they won't just cancel. You would still have some terms remaining. But if your term is super linear, which is AFn is equal to AFn minus 1 plus something, subtraction something or whatever, then you can definitely apply cancellation method. Super easy and super kind of fast to get the answer. Okay, but in many cases you cannot apply cancellation. You try it, but it does not work out. Okay, so you move on to the substitution method or the tree method. Hadi has a question. जोर से बोलो. हाँ. Okay, good. ठीक है. So what I was saying is, मेरे पास this is given. ये जो grey box में लिखा हुआ है ना, ये this is my input. Okay, and I want to find out value of a of n without a terms. Closed form चाहिए मुझे. Okay, तो मैं ये कह रहा था इस function के अंदर, this is a function of n है ना, मैं इसके अंदर अगर n की जगह n minus 1 put करूँ, तो I would get a of n minus 1. Okay, n की जगह पे अगर n minus 2 put करूँ, तो I would get n minus a of n minus 2. यहाँ पे a of n minus 3 होगा, and so on. If I keep going, I would start from n and I will go up till a of 1. Okay, ये सारी terms अगर मैं लिख लूँ, तो I would get n equations. ठीक है, अब इन n equations को अगर मैं sum कर लूँ, I want to sum, yeah, I want to sum. Okay, तो मेरे पास कुछ terms left पे होंगी और कुछ terms right पे होंगी. The thing is, इसमें इस case के अंदर, for example, बहुत सारी terms ऐसी हैं जो left पे भी हैं और right पे भी हैं. Okay, so a of n minus 1 left पे भी है और right के ऊपर भी है, which means कि वो boy, my punchline is ruined. Which means कि मैं उसको cancel कर दूँगा. Okay, अगर मैं उनको cancel कर दूँ, तो left के ऊपर I would just be left with a of, okay, and right के ऊपर I would just be left with 2 times n, 2 of n minus 1, 2 times n minus 2 and so on, जो भी terms रहें. ठीक है, तो इन चीज़ों को मैं sum कर लूँगा और मुझे आंसर मिल जाएगा. ज़ोहा, sorry what? A of 0 क्यों है? A of 0 क्यों है? So ये stopping condition है. Okay, ये उस algorithm की stopping condition है. उस algorithm को आप एक list of numbers to, for example, sort करने के लिए दे रहे हैं, और जब आप उसको एक empty list send करते हैं, which means कि number of numbers in that list is 0, वो algorithm just return कर देता है. Okay, there is nothing to sort here. Okay, so that's what a of 0 says.
0 put करेंगे तो 1 आएगा, तब वहाँ पे stop हो जाएगा.
Yeah. So it's a stopping condition. You can have different stopping conditions. They are usually, for algorithms case, they are usually a constant number. Okay, which means कि मेरे algorithm, मेरी अगर list का size 5 हो गया या 10 हो गया, तो फिर इतना ज़्यादा algorithm को काम करने की ज़रूरत नहीं है. वो constant काम करेगा और spit out कर देगा जो solution है. Okay, but there is always a stopping condition. Okay, it's not very important. Okay, for algorithms case. Okay, but it's always there. Okay, good. So that's what cancellation method is, and the drawback, demerit is it does not apply to most important cases. Okay, Hanan, are we good? Kazmi sir. Okay. Okay. So this is the final solution. Okay, we know how to do this, so I'm going to skip this part. And this is the final line. Algorithms के case में this is what you want. You want to say that this algorithm takes order n square time. Okay.